Crawler bulldozer. The crawler bulldozer is the machine most people picture when they think of a bulldozer. Instead of riding on wheels, it moves on two continuous steel tracks that give it exceptional traction and stability. This design allows it to push enormous amounts of soil, rock, and debris across terrain where many other machines would struggle to gain a firm grip. The origins of the crawler bulldozer can be traced back to the early 20th century, when tracked agricultural tractors began replacing horse-drawn equipment on farms. Engineers soon realized that these powerful track machines could do much more than plow fields. By adding a large steel blade to the front, they created a machine capable of reshaping the landscape itself. Over time, hydraulic systems replaced cables and manual control, giving operators precise command over the blade and transforming the bulldozer into one of the most important machines in modern construction. Its greatest strength comes from the tracks beneath it. Because the machine's weight is spread over a large surface area, ground pressure is reduced while traction is increased. This allows the bulldozer to climb steep slopes, cross rocky ground, and continue working even when the soil is loose or muddy. The tracks also provide remarkable stability when pushing heavy loads that would overwhelm a wheeled machine. The front blade is what gives the crawler bulldozer its distinctive purpose. Rather than digging like an excavator, it pushes material forward, clearing land, leveling surfaces, and moving massive volumes of earth in a single pass. At the rear, many crawler bulldozers are equipped with a ripper, a powerful steel attachment that breaks apart compacted soil, frozen ground, or solid rock before the blade moves the loosened material away. These machines are used in nearly every major earth-moving project. They prepare building sites, construct roads, build dams, open mining operations, clear forests, and assist in disaster recovery after landslides and earthquakes. Whenever raw power and traction are required, the crawler bulldozer is usually the first machine to arrive. Although it travels much slower than wheeled equipment and often requires transport between distant job sites, its unmatched pushing force makes speed a secondary concern. For more than a century, the crawler bulldozer has remained one of the most trusted machines for shaping the land on which modern civilization is built. Wheel bulldozer. The wheel bulldozer performs many of the same tasks as a crawler bulldozer, but it achieves them using four large rubber tires instead of steel tracks. This seemingly simple difference changes the machine's capabilities in several important ways, making it better suited for specific working conditions. As construction expanded into urban environments and industrial facilities, contractors often needed a machine that could move quickly across hard surfaces without damaging roads or concrete. Steel tracks provide tremendous traction, but they also wear paved surfaces and limit travel speed. Rubber tires solved both problems, allowing the bulldozer to drive rapidly between work areas while minimizing damage to finished ground. A wheel bulldozer is generally faster and more maneuverable than a crawler model. Its articulated steering system allows the machine to turn within relatively tight spaces, making it useful in stockyards, quarries, ports, recycling centers, and large industrial sites where frequent movement is required throughout the day. Because the tires provide less contact with the ground than tracks, wheel bulldozers are not ideal for deep mud, steep slopes, or loose sand. However, on firm surfaces such as gravel, compacted soil, asphalt, and concrete, they perform exceptionally well. Their higher travel speed often allows operators to complete jobs more efficiently when pushing material over shorter distances. The blade functions much like that of a crawler bulldozer, clearing debris, leveling surfaces, and moving loose material. Many models are also designed to handle lighter grading work where precision and mobility are more valuable than maximum pushing force. Another advantage is lower maintenance in certain environments. Tires can be easier to service than complex track undercarriages, particularly when the machine spends most of its time on prepared surfaces rather than abrasive rock or muddy terrain. While the crawler bulldozer dominates heavy earthmoving, the wheel bulldozer fills an equally important role wherever speed, mobility, and maneuverability are priority. It demonstrates that not every construction project demands maximum traction. Sometimes efficiency comes from moving quickly rather than pushing harder. Mini bulldozer. The mini bulldozer brings the essential capabilities of a full-sized bulldozer into places where larger machines simply cannot operate. Built on a much smaller frame, it is designed for confined work areas that require precision rather than overwhelming power. Its popularity grew alongside residential construction and urban development. Contractors working between existing buildings, inside industrial facilities, or in landscaped environments needed equipment capable of grading and pushing material without occupying the space required required by heavy construction machines. The mini bulldozer answered that need by combining compact dimensions with surprising versatility. Although considerably smaller than standard bulldozers, the machine still performs many of the same tasks. It can level soil, prepare foundation, backfill trenches, clear debris, and shape landscapes with remarkable accuracy. The smaller blade gives operators greater control, allowing them to make fine adjustments that would be more difficult with larger equipment. Most mini bulldozers use rubber tracks instead of steel tracks. These provide excellent traction while reducing damage to finished surfaces such as sidewalks, driveways, and lawns. The lighter overall weight also reduces ground pressure, making the machine suitable for delicate landscaping projects where minimizing surface disturbance is important. Modern mini bulldozers often feature advanced hydraulic controls and compact diesel engines that deliver impressive performance relative to their size. Many are equipped with laser or GPS grading system, enabling operators to create highly accurate slopes and elevations for construction projects that demand precise finishing work. Their compact dimensions also simplify transportation. Unlike full-sized bulldozers that usually require heavy transport trailers, many mini bulldozers can be moved using smaller trailers behind medium-duty trucks. This allows contractors to relocate equipment quickly between multiple projects in a single day. While they cannot replace large bulldozers on major earth-moving operations, mini bulldozers excel at detailed work where precision, accessibility, and efficiency matter more than raw horsepower. They have become indispensable tools for landscaping companies, utility contractors, residential builders, and property developers. Low ground pressure bulldozer. The low ground pressure bulldozer, often called an LGP bulldozer, is specially designed to work where ordinary heavy equipment would sink under its own weight. Instead of increasing power, engineers focused on distributing the machine's weight across a much larger area, allowing it to travel safely over soft and unstable ground. The most noticeable feature is its extra-wide track. Compared with a standard crawler bulldozer, an LGP model uses significantly broader track shoes that spread the machine's weight over more surface area. This greatly reduces the amount of pressure applied to the ground beneath it. The principle is similar to how snowshoes help a person walk across deep snow. Without them, body weight is concentrated into a small area and quickly sinks. By spreading that weight over a larger surface, the pressure decreases, allowing movement across terrain that would otherwise be impossible. This specialized design makes the LGP bulldozer invaluable in wetland, marshes, peat fields, reclaimed land, and other locations where soil lacks the strength to support conventional construction equipment. It is also widely used in pipeline construction, environmental restoration, and land reclamation projects where preserving fragile ground conditions is essential. Although the wider track improves flotation, they do introduce certain limitations. Transporting the machine can be more complicated because of its increased width, and on hard, rocky terrain the wider track shoes may wear differently than standard configuration. Even so, these compromises are small compared to the advantages gained in soft ground environments. The LGP bulldozer demonstrates that successful engineering is not always about adding more power. Sometimes the key is understanding how weight interacts with the ground beneath the machine. By simply changing the way that weight is distributed, engineers created a bulldozer capable of working in places that were once considered inaccessible for heavy equipment. Swamp bulldozer. The swamp bulldozer is built for some of the most challenging terrain a construction machine can encounter. At first glance, it resembles a standard crawler bulldozer, but a closer look reveals much wider tracks and a specially designed undercarriage that allows it to travel across deep mud, marshes, peat bog, and waterlogged ground without sinking. The machine was developed as engineers and contractors began taking on projects in wetland, coastal region, and flood-prone areas where conventional bulldozers frequently became trapped. Rather than increasing engine power, manufacturers focused on reducing ground pressure by spreading the machine's weight over a much larger surface. The result was a bulldozer that could remain productive even in terrain that seemed impossible to cross. Its oversized tracks are the key to its performance. Each track shoe distributes the machine's weight more evenly across the ground, creating a floating effect that helps prevent the bulldozer from digging itself into soft soil. While it still cannot operate in deep open water, it can confidently travel through conditions that would stop many other heavy machines within minutes. Swamp bulldozers are commonly used to build levees, maintain drainage canals, construct pipelines through wetlands, prepare sites for bridges, and restore flood control systems. They also play an important role in environmental projects where access to remote marshland is necessary for habitat restoration and erosion control. Many models are equipped with sealed undercarriages that help protect moving components from mud, water, and debris. Additional guarding around hydraulic lines and drive systems also improves reliability when operating in abrasive or highly saturated conditions, where maintenance can become especially challenging. Although they are slower than standard crawler bulldozer and less effective on hard, rocky terrain, swamp bulldozers excel precisely where other machines fail. Their ability to maintain traction in extremely soft ground makes them an indispensable tool for projects that take place at the boundary between land and water. Angle dozer. The angle dozer is designed for moving material to one side rather than pushing it straight ahead. The difference lies in its blade, which can be angled left or right, allowing soil, gravel, snow, or debris to roll off one side as the machine moves forward. This design became popular as contractors searched for faster ways to clear roads and shape long stretches of ground without making repeated passes. Instead of pushing material into a pile directly in front of the machine, the angled blade continuously directs it away from the work path, creating a smoother and more efficient operation. The blade can usually be adjusted hydraulically from inside the operator's cab. This allows the driver to change the blade angle while working, adapting to different terrain and material conditions without stopping the machine. On modern bulldozers, these hydraulic controls offer smooth and precise adjustments that improve productivity throughout the day. Angle dozers are especially valuable for road construction, site grading, ditch maintenance, and snow removal. When clearing a roadway after heavy snowfall, for example, the angled blade pushes snow toward the roadside in one continuous movement instead of requiring repeated forward and back operation. The design is also useful when shaping embankments or maintaining drainage channels. By directing loose material to one side, operators can create consistent slopes while reducing the amount of additional grading required later. Although an angle blade cannot carry as much material as some other blade designs, its ability to move material sideways often makes it the faster and more efficient choice for long, linear projects where constant redirection of material is more important than maximum pushing capacity. Straight blade bulldozer. The straight blade bulldozer, often called an S-blade bulldozer, uses the simplest bulldozer blade design. The blade is relatively short from side to side, has no large curved wings on its edges, and is intended primarily for pushing, cutting, and leveling material over short distances with excellent control. Despite its simplicity, the straight blade remains one of the most widely used bulldozer configurations. It provides a direct transfer of force from the machine into the material being pushed, making it highly effective for precise grading and finishing work, where accuracy is more important than carrying large volumes of earth. Its flat shape allows operators to strip topsoil, level construction sites, and create smooth working surfaces with consistent results. Because the blade does not trap material as aggressively as larger curved design, it offers better visibility and finer control during detailed operation. The straight blade is commonly found on projects that require careful shaping of the ground before concrete foundation, roads, or industrial facilities are built. Contractors also use it to spread fill material evenly across large areas, ensuring the finished surface meets strict engineering specifications. Many experienced operators appreciate the predictable handling of an S-blade. The machine responds directly to steering and blade adjustments, making it easier to maintain precise elevations over long distances. This level of control is especially important when working with laser-guided or GPS-controlled grading systems that demand extremely accurate results. While it may not move the greatest volume of material in a single path, the straight blade excels at creating clean, level surfaces. It demonstrates that in construction, precision often matters just as much as raw pushing power. Universal blade bulldozer. The universal blade bulldozer, commonly known as a U-blade bulldozer, is built to move the largest possible volume of material in a single path. Its blade is taller than a straight blade and features large curved wings on both sides that help trap soil, sand, gravel, and other loose material as the bulldozer pushes forward. This blade design was developed to improve productivity on massive earth-moving projects. Engineers recognized that much of the material being pushed by conventional blades spilled off the sides before reaching its destination. By adding tall side wings and increasing the blade's curvature, they created a design that held material more effectively throughout the pushing process. As the bulldozer advances, the curved blade naturally funnels pulls loose material toward the center, while the side wings prevent it from escaping. This allows the machine to transport significantly larger loads over greater distances before unloading them, reducing the total number of passes needed to complete large-scale earth-moving operations. Universal blade bulldozers are commonly used in mining, dam construction, highway development, quarry operations, and large land-clearing projects where enormous quantities of soil or rock must be relocated efficiently. Their ability to carry heavy loads makes them particularly valuable whenever productivity is measured by the number of cubic meters moved each hour. Because the blade is larger, operators must carefully manage machine balance and visibility, especially when pushing a fully loaded blade uphill or across uneven terrain. Modern hydraulic systems and advanced operator controls help maintain stability while allowing precise adjustment of blade height and angle throughout the operation. The universal blade bulldozer represents one of the most efficient earth-moving configurations ever developed. By maximizing the amount of material carried with each pass, it reduces fuel consumption, operating time, and overall project costs on some of the world's largest construction and mining sites.